This is P3, the start of the electricity section. So P3.1a, describe that charge is a property of all matter and that there are positive and negative charges. Describe the production of static electricity and sparking by rubbing surfaces and evidence that charged objects exert forces of attraction or repulsion on one another when not in contact. Explain how transfer of electrons between objects can explain the phenomena of static electricity. Explain the concept of an electric field and how it helps to explain the phenomena of static electricity. Recall that current is the rate of flow of charge, in this case electrons, for electricity, the common electricity, and the conditions needed for charge to flow. Recall that current has the same value at any point in a closed loop. Recall and use the relationship between quantity of charge, current, and time. Alright, so if you look at the top right, you've got a diagram for the atom where the protons and neutrons are inside the nucleus and you've got electrons orbiting around the nucleus. And we just say that the protons are positively charged and we say that the electrons are negatively charged. It's just that we assign them as positive and negative. If we had called the protons as negative, then the electrons would have been positive. So as long as they are oppositely charged between the protons and the electrons, then these are charges that we know of. So the protons are positively charged and the electrons are negatively charged. And inside the nucleus, you also have neutrons, because the neutrons, they are also subatomic particles, but they are uncharged. Alright, so the electric charge, which can be positive or negative, occurs in discrete units, and in this case the electron has the smallest electric charge. So the charge of the electron will be 1.6 times 10 to the minus 19 coulombs. When I say discrete, I mean like it is not continuous. So for example, the smallest unit of electric charge is the unit for the electron. So the unit for the smallest charge is the same as the charge of the electron. Now, we know that in metals, for example, group 1 metals and group 2 metals, they have delocalized electrons. So for group 1 metals, group 2 metals, they've got 1 electron in the outer shell and they have got 2 electrons in the outer shell. And that makes it delocalized, meaning that the electrons are very far away from the nucleus. It is able to move around the metal, freely moving. So materials that do not allow charges to move easily are called electrical insulators. And the electrons that travel freely are called electrical conductors. So only insulators are good at retaining static charge, because if the metals were to gain charge, then they are able to move around more freely than insulators. Now what we have here are diagrams for the electric field. So if you imagine a positive test charge outside a positive charge, where will the positive charge go? So it would go outwards. So for a positive charge, it would go outwards, because in this case, the positive test charge would be going away from the other positive charge. It will be repelled. So that is why the positive charge will have arrows pointing out of it as the electric field. For the negative charge, if you imagine a positive test charge on the outside, where will the positive test charge go? The positive test charge would go towards the negative charge, so it will go inwards. So for a negative charge, it will go in towards the negative charge. Now, if you look at the top left, if you have a positive charge and a negative charge, these are the field lines. So the positive charge would go towards the negative charge, and the lines are shown as follows. So remember that the positive charge will always go towards the negative charge. Now, if you have two positive charges, they won't go towards each other because they will repel. So if you look at the bottom diagram, the one that says 2, the field lines will go away from the positive test charge, but then because they're being repelled, they will never join. So the field lines don't join. What is the definition of current? So the current in this case is the flow of charge. Now, to be more specific, the current is the rate of flow of charge. So the equation I is equal to Q over T, where I is current measured in amps, Q is charge measured in coulombs, and T time measured in seconds. So this equation tells us that the charge is flowing past a point A. In this case, A is the surface area, if you look at the bottom left. So if you have more charges passing through that surface area per second, the current will go up. And if the charge is flowing very quickly, meaning it takes less time for it to flow past that point, then you can say the current is also quite high. So that is the equation. I is equal to Q divided by T. If you look at this diagram here, this is about static electricity. So if you look at this diagram, you've got the atoms where the electron on the left-hand side is transferred to the right-hand side. Now, there's something called an adhesive force. So let's have a look at the definition. So a force called the adhesive molecular force holds materials together. If two different materials are pressed together and then pulled apart, the adhesive molecular force can pull electrons from one material and go to the other. This creates the separation of charges or static electricity. So if we go back, so static electricity is usually caused by friction between two different objects, where one electron, if you look at each atom, one electron will be transferred to the other object. Now the reason for this is because friction. Okay, we'll talk about that later. Because smooth surfaces, if you look in a microscope, they're not actually smooth. They're actually very rough. But for the moment, as you are, when you put two different objects close together, electrons can be transferred from one object to the other. Right, so the electric field is a regional space where charged particles experience a force. So if you look at the top left, where you have a plate of positive charge and a plate of negatively charged, if you were to put an electron inside, the electron will feel a force towards the positive plate and be repelled by the negative plate. So it would accelerate, it would experience a force. Similarly, if you have a positive charge in between a plate where it's positive and negative, the positive charge will go towards the negative and it will be repelled by the positive. So a charged particle inside an electric field will experience a force. This is just something that's extra, but it's quite useful to understand what's going on. So if you look on the right hand side where you've got two rectangular blocks resting on each other, it looks smooth if you look at it far away, but then when you zoom in, you can see it is very rough. Alright, so let's read. All materials have a molecular structure, and when that structure is bent in irregular ways, that shifting can create an electric charge. So if you look at the bottom left, where you got these rough surfaces, and then you apply friction, so you're rubbing two objects close together. What you're doing is that you're bending the shapes, so you're bending the electron clouds. So I'm just reading now the second box. Tiny protrusions on the surface of the material create polarization when they are bent. This effect, known as Flexo Electricity, is then what causes static electricity. Even surfaces that look completely flat are covered with small protrusions at the nanoscale. So this is called Flexo Electricity, where you have deformation of the surfaces between two objects, and that results in electrical distributions. So this is an extra slide. So static electricity is produced when the asperities. Now the word asperities means the rough surface of materials. So for example, you get peaks and you get troughs. So where the surface becomes high and low on a quotes smooth unquote smooth surfaces. So it's when the roughness in the surfaces in the insulators rub against each other and interfere with the electron clouds. Since the electrons in the insulators can't move around easily, that rubbing can bend the electron clouds out of shape. And then what happens when you squeeze that cloud? It deforms and it becomes asymmetrical. And then under the right circumstances, the new shape will distribute voltage unevenly across the material. Now what that means is that the voltage, one side becomes more positive, one side becoming more negative. And then that can distribute the voltage unevenly across the material. And that causes the electrons to be transferred from one object to the other. Okay, so let's have a look at this diagram. So if you look at the ebonite rod, which is negatively charged, and that is brought close to a metal sphere. Now, originally, the metal sphere is uncharged, meaning that you have delocalized electrons and you've got positive metal ions in it, and they are evenly distributed. However, if you bring that ebonite rod very close to that uncharged metal sphere, the electrons will move to the other side because it's being repelled, and then you've got the positive metal ions being moving slightly closer towards the negatively charged rod, because the metal ions are more or less stuck in place. It is only the delocalized electrons that are able to move. So it is the delocalized electrons that are moving towards the right, and the metal ions moving a bit towards the left. Now, what happens if you connect a wire from the negative end of the sphere and connect it to the ground? What happens is that the electrons will go straight to the ground. So you can remove those excess electrons on the sphere to the ground. So that is called grounding wire. So the word grounding meaning removing excess charge from something towards the ground, or something that has a large surface area. In this case, the ground has a large surface area to distribute the charge. And what happens when you remove that excess negative charge? Well, now the sphere becomes positively charged in C. So if you look at this diagram here, the metal sphere has delocalized electrons. It is able to move freely. I'm looking at the arrow at the bottom. Neutral, meaning evenly distributed charges, no unbalanced charges. The excess electrons will go towards the ground. Now this is referring to diagram B. So because they're also being repelled by other electrons, because they're being repelled, and because the wire should be made of a metal and it has delocalized electrons, the electrons can go from one place to the other. And if you look at diagram A, as the ebonite rod is brought close to the neutral metal sphere, because only electrons move, and because they are moving around the nucleus, the electrons get repelled moving to the right hand side. The metal ions will more or less stay in place, but they will be moving slightly towards the left. So when that says REP, that means it is repelled towards the right hand side. And sometimes the ground can be more positive. If you think about the heavy atoms on the ground, and then you've got the sun's rays, the sun's radiation hitting the atoms, sometimes they will hit the electrons, making the electrons escape from the nucleus of the atom. That makes it positively charged because the electrons have escaped. That means that the atoms have become ionized, leaving them positively charged close to the ground. This is a similar diagram. So if you have a positively charged rod and you bring that close to a neutral metal's sphere, the delocalized electrons will move towards the positively charged rod because opposites attract, and then the metal ions will be slightly displaced to the right hand side. Remember, the metal ions can't really move that far, so they're just slightly displaced towards the right, and the negative delocalized electrons will move towards the positively charged glass rod, so it will be moving towards the left. Now, what you have is that you've caused a voltage now, haven't you? If you have any separation of charges, you've caused a voltage. You've caused a potential difference. So if one side is more positive and one side is more negative, you have set up a voltage. All right, so have a look at these summary questions. You should pause it, and then I'll go to the next slide where there are answers. All right, so what causes an electric spark? If one side is more negative than another, so one is positive and one side is negative, that means that you will have excess electrons on the negative side. What happens when you bring the positive side closer towards the negative side? Well, because you've separated those two charges, you have created an electric field. The electrons will always want to go somewhere which is positive because opposites attract, and also because you've created an electric field, a negatively charged particle will go towards a positive side. So a static electric spark happens when an object with a surplus of negative electrons comes close to another object with a less negative charge, meaning more positive. That makes the electrons jump. And because the charges were separated, that has caused an electric field, and any charged particles within that electric field will experience a force. This transfer of electrons, what we know is a spark of static electricity. For example, when feet shuffling across the carpet, or when someone removes their wool gloves to shake hands. But it happens more frequently when there's low humidity, because dry air is an electrical insulator, where moist air it will conduct electricity more easily. So in dry air, the electrons get trapped on the surface with the stronger binding force. Because when air is moist, the electrons are able to flow between the water molecules. So unlike when the air is moist, they can't find their way back to flow. They can't find their way to flow back to the surface where they came from, and they can't make the distribution of charges uniform again. So the answers are here. The answers on the right hand side. You can pause. And here are some questions. Attempt these questions and then I'll show you the answer now. So pause and then I'll show you the answer. So the answers are here on the slide. And here another question. So try to answer these questions and then move on to the next slide. Pause and then try to answer. So the answers are here. And a question. And then read the question, pause, and then the answers are coming up soon. So here are the answers. So here we have a question. So pause and read the question and try this question out for yourself. And I'll show you the answer that's coming up soon. So the answers are there on the board, on the slide. Okay, so let me just read these questions out very quickly. So what does it mean for an object to have an electric charge? Give an example of an object receiving an electric charge and describe how that charged object might behave. Question 2. So I know it's not numbered, so the first question is at the top, the second in the middle, and the third at the bottom. So how many electrons are contained in 1 coulomb of charge? That's number 2. Number 3, what is happening when two objects are rubbed together and static electricity results? So try to answer the questions, pause, and then I'll show you the answer. Right, so the answer. For an object to be electrically charged, it must have either a surplus surplus or a deficit of electrons among its atoms. How many electrons are contained in 1 coulomb of charge? There are 6.25 times 10 to the power of 18 electrons in 1 coulomb of charge. Now, you don't need to memorize this. You can just remember that it is in the range of 10 to the power of 18 electrons, or 10 to the 19, because the charge of one electron is 1.6 times 10 to the minus 19 coulombs. So you do 1 over that number. What is happening when two objects are rubbed together and static electricity results? When certain combinations of materials are rubbed together, the rubbing action transfers electrons from the atoms of one material to the other. This imbalance of electrons leave the former material with a positive charge and the latter with a negative charge. So the one where it gains the electrons become negative, and the one that loses electrons become positive. And if you have a separation of charges, you end up with an electric field. Alright, so let's look at grounding then. So if you remember that diagram I showed you earlier, this is just another diagram. So what happens if you bring a negatively charged object close to a neutral metal sphere? Well, the electrons get repelled because they're delocalized, and you can ground the excess electrons by connecting a wire to the metal sphere to the ground. Number one, because the metal is made up of delocalized electrons, and it is able to make the charges move more freely. So therefore you can ground using a metal wire to remove excess electrons from the sphere, and then that will leave a positively charged sphere on the right hand side. So grounding is the process of removing excess charge on an object by means of the transfer of electrons between it and another object of substantial size. When a charged object is grounded, the excess charge is balanced by the transfer of electrons between the charged object and the ground. When a charged object is grounded, the excess charge is balanced by the transfer of electrons between the charged object and a ground. So that is just a repetition of the above. So if you look on the right hand side, when polythene is rubbed with a woolen cloth, the polythene pulls electrons from the wool. Right, so more electrons from because there are more electrons in the polythene, that makes it more negative. The electrons are transferred by rubbing. So the electrons go from the wool to the polythene. That makes polythene more negatively charged and the pool more positively charged because there are fewer electrons than normal. So when the polythene is rubbed with a woolen cloth, the polythene removes the electrons from the wool, leaving the polythene with a negatively charged, leaving it negatively charged, and leaving the wool positively charged, and that creates an electric field.